Imagine a giant fireball millions of times bigger than Earth. Now, picture it erupting with a ferocious burst of energy, a blinding flash that could outshine a billion suns combined. This, my friends, is a solar flare, a celestial dance of fire and magnetism playing out on our very doorstep. But these fiery outbursts aren't just a light show. They can unleash a torrent of charged particles that races across the solar system. And guess what? Earth is right in its path, so buckle up, because in this video we're diving deep into the heart of a solar flare to unravel its secrets and discover how it can impact our world. In the cosmic theatre of our universe, the sun recently played a rather dramatic act. In the otherwise serene celestial landscape, a sudden lash of energy painted a vivid scene, an M7, 4-class solar flare, a magnificent spectacle of Mother Nature's fiery temperament. On the 10th day of March, a rather unassuming protagonist, sunspot AR 3599, took center stage. In an unexpected twist, it unleashed a powerful solar flare, a burst of electromagnetic radiation triggered by a buildup of magnetic energy in the sun's atmospheric layers. This solar tantrum led to an extensive radio blackout across the vast expanses of Africa and the South Atlantic for up to 30 minutes. Accompanying this flare was a coronal mass ejection, or CME for short, a significant release of plasma and accompanying magnetic field from the solar corona. Traveling at a staggering speed of 1.7 million miles per hour, the CME is predicted to pass ahead of Earth, potentially causing minor geomagnetic storm conditions. The GOES, geostationary operational environmental satellites operated by NOAA, National Oceanic and Atmospheric Administration, are the primary instruments used to measure solar X-rays. These satellites are positioned in a geosynchronous orbit, allowing for continuous monitoring of the sun. Yet, the solar drama didn't end there. On March 17th, another CME erupted from the sun, heading towards Earth and potentially causing another geomagnetic storm. NASA's Solar Dynamics Observatory recorded this CME, intriguingly dubbed a canyon of fire, expected to graze Earth's magnetic field on the 20th of March. This upcoming geomagnetic storm holds the potential to instigate auroras in high latitudes, coinciding with the vernal equinox and the Russell-McFerran effect, which renders Earth's magnetic field vulnerable to even minor solar winds during this period. Solar flares, in essence, are intense bursts of energy associated with sunspot groups typically occurring in active regions of the sun. They are classified into distinct categories, X-class flares being the most powerful, followed by M-class, C-class, B-class and A-class flares. The recent solar flare was classified as an M7, 43, a powerful flare in its own right. The sun, our life-giving star, recently demonstrated its unpredictable and tempestuous nature. The sudden burst of an M7 4-class solar flare from sunspot AR 3599, followed by a fast-moving CME, has set the stage for potential geomagnetic storms on Earth. Coupled with the upcoming Canyon of Fire CME, we may witness enchanting auroras at high latitudes, a celestial ballet orchestrated by the intricate interplay between solar activity and Earth's magnetic field. Solar flares, while impressive displays of the sun's power, can have a mixed bag of effects on Earth. Here's a breakdown of and negative impacts. Radio blackouts. Strong flares can disrupt radio waves in the Earth's ionosphere, hindering communication for everything from airplanes to emergency services. This can last from minutes to hours. GPS glitches. The accuracy of GPS signals can be affected by solar flares, impacting navigation systems for both civilian and military use. Power grid damage. In extreme cases, a powerful solar flare can induce strong currents in power grids, overloading transformers and causing widespread blackouts. The Carrington event of 1859 is a historical example, causing sparks to fly from telegraph lines. Satellite disruptions. The increased drag from a heated atmosphere due to solar flares can shorten the lifespan of satellites in low Earth orbit. Additionally, sensitive electronics on board can be damaged by the radiation burst. We previously covered methods of communication that could be useful in the event of an internet blackout, LoRa and LoRaWAN. But these technologies are also not immune to solar flares and may be disrupted temporarily. Do you wonder how man-made objects in space survive these onslaughts? Satellites and the International Space Station, ISS, have varying levels of protection against solar flares due to their location and design. The biggest advantage for both ISS and many satellites is their location in low Earth orbit. They benefit from the protection offered by Earth's magnetosphere, a giant magnetic field that deflects most of the charged particles released during a solar flare. In addition, many satellites are designed with special shielding around critical electronic components. This shielding can be made from aluminum or other materials that absorb or deflect radiation. The specific type and amount of shielding used depends on the satellite's function and its expected exposure to radiation. The ISS has specific modules designed to provide shelter for astronauts during a solar flare event. These modules have thicker walls made of aluminum and other materials to offer superior radiation protection. There are currently no ways to completely prevent humans from being affected by solar flares, as these are natural phenomena. However, there are several measures being taken to mitigate the risks and protect human infrastructure. Space weather monitoring, a global network of telescopes and satellites, continuously monitors the sun for signs of solar activity. This allows for early warnings of potential flares, giving us time to prepare. International collaboration, the National Oceanic and Atmospheric Administration, NOAA, in the US, works with similar agencies worldwide to share data, forecasts and warnings about solar storms. Power grid upgrades, utilities are exploring ways to strengthen the power grid against the effects of solar flares. This could involve installing special transformers that can withstand surges caused by induced currents, or developing alternative power distribution systems less vulnerable to geomagnetic storms. The military is particularly reliant on satellites and communication systems. They are actively researching and implementing measures to ensure their continued operation during solar events. This might involve hardening electronic components or having backup systems in place. Government agencies are developing emergency response plans for dealing with the aftermath of a major solar storm. This could involve prioritizing critical infrastructure repairs, ensuring communication channels remain open, and managing potential disruptions to essential services. Educating the public about the potential risks of solar flares and basic preparedness steps can help individuals and communities cope with the effects of a solar event. This could include stocking up on emergency supplies, having alternative communication methods available, and following official instructions during a solar storm. As we continue to gaze upon the cosmic theatre, we're reminded of the sun's mercurial temperament and the captivating drama it plays out. A drama filled with solar flares, CMEs, radio blackouts, and geomagnetic storms. A drama that, while grounded in the realm of science, still manages to retain an air of mystery and intrigue. Solar flares got you curious? Like this video and subscribe to SciSips to stay informed about all things space.